Today we're going to talk about functions. Um, so this idea of a function is so critical to the study of calculus. Okay, in this unit we're going to look at characteristics of all functions. Okay, what are the things we want to look at for all types of functions? Then in the rest of the course we'll spend that time talking about specific types of functions and their applications, okay, but keeping in mind all these general characteristics that we're going to talk about in this unit. So what is a function? We're going to start by looking at an example here, okay? So Miss Wainscott has a document that lists seniors who drive to school and their parking spaces. Okay, um, this shows a relation or a correspondence between the set of students and the set of parking spaces. So we can represent this in several ways. So we could create a table, right? You could have one column with a list of students. You could have the other column with the list of parking spaces. You could even list them as ordered pairs. Okay, right. So you could have a list that lists the student, okay, and their parking space. Okay, and that's really just an ordered pair, right? Okay, and we could even talk about it as a graph. Okay, we could make a chart. We could plot this, and we could have students on this axis. Okay, I could have a student name there, student name there, student name there, and then I could have the parking space numbers. Okay, um, and so we could even graph it, right? And so each student would correspond with a parking space. It might not mean anything, okay, um, but we could graph that. Okay. Another way we can represent functions is a mapping, and so and this is going to help us understand the formal definition of what a function is. So let's say we have two sets, okay, and a set is just a collection of objects, okay, or of things. So we'll call X the set of all seniors who drive, okay, and so you have in this you have senior number one. We'll just number them senior number two, senior number three, and senior number four, okay, etc. And you would list all the seniors. Okay. The next set, okay, we'll call Y the set of all parking spaces at St. X. Okay, um, and so we have all of our parking spaces, and they're numbered. Okay, so this could really just be a set of numbers, right? 1, 2, 3, 4, 5, 6, etc. And so we have these two sets. And so what a mapping does is it shows the correspondence between those sets. So let's say senior number one gets assigned parking space number two. Okay, and um, we call that correspondence. Okay, we label this. We talk about this set here as being the domain. Okay, and so senior one is an element in the domain, and this 2 here, okay, 2 is this becomes the image of senior one. So this is the image of senior one. Okay, So that's the image of the element in the domain. Okay. And senior 2, let's say senior 2 got spot number 1. Okay, and senior 3 got spot number 3. And senior 4 gets spot number 4. Okay, and so on. Okay, and so we can make this correspondence anything we want. Okay, and so we look at this collection. Okay, so all of these images, this collection of all of these images, so all the spots that get assigned to seniors, this is called the range. Okay, so the domain is a set of all the inputs, and the range is a set of all the outputs. Okay, and notice I still have some other objects out here that aren't in the range. Well, these could be assigned to seniors, but also remember we have other people parking on campus besides just seniors, right? Juniors park on campus, faculty, staff park on campus. So just the set that corresponds with all of our seniors, because this is the set of all seniors. Okay, so the range is going to be the set of all parking spaces assigned to seniors. Okay, and so we could have some things in this set of all parking spaces that aren't technically in the range of this. Okay, but this relationship here is a function. Okay, a function is a special type of relationship where each element in the domain, okay, corresponds with exactly one element in the range. So each senior only gets one parking space, right? Nobody's going to be assigned 2 parking spaces unless you're super special. Okay, and so let's look at the formal definition here. So from the text we have let x and y be 2 non-empty sets. Okay, so we have our 2 sets x and y. A function from x into y is a relation that associates with each element in here exactly one element of y. Okay, and so I encourage you to think of it in this way. Okay, this domain, this is the set of inputs, and our range, okay, is the set of outputs. And so another way to talk about this definition is a function is a relationship, okay, where every input has exactly one output. Okay. Each senior is assigned 1 parking space. That's a function. Okay. I'll have some videos on Khan Academy posted that talks about, well, how do you identify functions from a graph or maybe from a table. Okay, but you're really just looking to check that every input has exactly one output. So whether you're looking at ordered pairs, or you're looking at a table, or you're looking at a graph, you're checking to make sure that each input has only one output.